Okay, I have three examples of removing common factors that are directly applicable. They're exactly the type of things that we'll be talking about in this class. So, here's a list of the three examples, and let's go ahead and get started. On the first example, so let's scroll down. So the first one was factor Factor 15a squared b cubed c squared plus 9a cubed b. Okay, well the first thing I want to do is list out the the individual terms, excuse me. So the first one is 15a squared b cubed c squared. Okay, so I'm going to go ahead and write that as, first of all, 15. Okay, let's do this over here. I don't need to I don't need to do a factor tree. I can just tell you now it's 3 times 5. Because 3 times 5 is 15, and those are both prime numbers. And then there's two A's. Two A's, 3 B's, and 2 C's. Okay, so that's the first term. The next term is going to be 9a cubed b, which is going to be 3 times 3 times a, sorry to put c, a, b. So we have 3, a, b. Okay, so let's see what we have in common. We have a 3 in common. We have an a in common. Another a in common. And we have one b in common. So what we have in common is 1 3, 2 a's, and 1 b. That's not very clear, is it? Okay, so that means that the 3a squared b is going to go on the outside. So let's go ahead and write that down on the next line. So 3a squared b, this part is going to go on the outside of the parentheses. So we have what's left on the inside is going to have 1 5 for the first term, 2 b's, so 5b squared, and then 2 c's. Okay, and what's left for the second term is just 3a. So this is going to be the final answer, but we can go ahead and check that answer pretty easily by multiplying these two things out. So we have 3a squared b times 5b squared c squared. Well, that's going to equal 15 a squared b cubed, because we have the b and b, so we have 3 b's altogether, b cubed c squared. Now we want to multiply these two things together. 9, because 3 and 3 is 9. We're going to have 3 a's, because we have 2 a's here and 1 a here, so 3 a's, and then 1 b. So I check this by making sure this matches what I was given. And it does. 15a squared b cubed c squared plus 9a cubed b. So that means that because this matches this, then this is most likely right. I mean, unless I did them both wrong in kind of weird ways. So there's a this part right here then is going to be the final answer. Alright, so let's go ahead and go to the next example. Here, let's go ahead and Factor 12ac minus 20c squared. Okay, so the first thing I want to do is I'm going to go ahead and do this with the mouse if there's no objection. So 12ac. So let's go ahead and write out the factors of 12 and a and c. So 12 is going to be, I already did this before, but I'll do it again over here. Is going to be 2 and 6, 2 and 3. So it's going to be 2 times 2 times 3 times a times c. And then 20, do this over here, 20 is equal to 2 times 10. This 10 is 2 and 5. So 20c squared, I've got the c squared, is going to be equal to 2 times 2 times 5. I want to kind of, you don't necessarily have to do this, and whenever I type this out I haven't done it, but I like to try to line it up as much as I possibly can. So like these 2's are going to be common, but since there's no 3's in common, I want to kind of try to leave this blank, sort of. I mean, it's not really, but I just like to line it up as much as possible. Then I have 2 c's. So you have 2 2's in common. 3 is only in 1, 5 is only in 1, a is only in 1. We have this c in common. So bear in mind though that order doesn't matter. If I had written this c over here, then this c would still be in common to both of them. That's why I like to line them up as much as I can, because that way I can see them more easily. So we can see that we have 2 2's in common and a c in common. So that means that what's circled is going to go on the outside of the parentheses. 2 times c will give you 4c. Then what's left for the first one is 3a. And what's left for the second one is 5c. So 4c times the, oops, I made a mistake. I made a big mistake. There should be a minus here. I'm glad I caught that. So whenever we have this, see, this should be minus c squared. So there's going to be a minus 1 out in front. So this is the first factor, is minus 1. I'm very glad I caught that. So this should be 3a minus 5c right there. So keep in mind that if it's minus here, it's going to be minus here. That's very important. So 4c, let's go ahead and, so this should be the final answer. Let's go ahead and double check it and make sure it's right. So we have 4c times 3a, that's going to give us 12ac, and 4c times minus 5c is going to give us minus 20c squared, and that gives us the original answer, the original problem, I should say. So that means that this, I'll go ahead and write it down again just to be more formal, I guess. 4c times 3a minus 5c is going to be our final answer. And just to make sure there's no confusion, I want to go over this one more time, this negative part here. So this will technically be the same thing as adding negative 20c squared. So that means that the negative 1 is a factor here. So that means it's going to be there in the end when we actually factor it out too. Now you don't necessarily need to write out that there's a negative 1 as a factor, just so long as you bear in mind that there's going to be a negative. If it's a negative here, it's going to be a negative here. Okay, so that concludes that example. Let's go ahead and clear that off. So let's go ahead and do, I did that entire thing using the mouse, I just realized. Oops, factor this last one. So 9x squared yz, okay, so this has 3 terms. So this is going to be a little bit trickier. Just not because it's really difficult, just because it's a little bit longer, since we have 3 terms instead of 2. So let's go ahead and list out these individual terms. So we have 9x squared yz. Okay, so 9 is going to be 3 times 3. Let's go ahead and put a little bit of space here, because I can see from this 6 that there's going to be a 2, so I'm going to want to make enough space for the next row for 2. So 3 times 3, and x times x. And we want to have 1y and 1z. So we have y, z. So for the next one we have 6x squared z equals 2. So see, now I have 2 and there's a blank in front of it, above it, 2 times 3, and then we have x times x times z. Let's make that a little bit more like an x. Okay, so then this next one is going to be 3xz equals 3xz. So one thing that's very important to understand is that the terms have to be common to all of them before you can factor them out, not just some of them. That means that this one doesn't count. We can't use that because it's not common to all of them. So what is common to all of them? Well, this 3 is common to all of them. This x is common to all of them. And this z is common to all of them. So that means that the outside of the parentheses is going to be 3xz. The inside is what's going to be left for each individual term. So what's left here is 3xy for the first term, plus 2x for the second term. So what's left for the third one? Well, nothing's really left, but there's an implied 1 here. A pretty common mistake is to just leave this out and just end it here, but that's not right, because you have to have an implied 1 there. And hopefully whenever you check the answer, you will catch that mistake. Because whenever everything is circled, whenever you factor out everything, what's left is a 1, an implied 1. Not plus 0, plus 1. So this, if I did everything right, should be the final answer. So let's go ahead and check it. So we can do 3, let's go, I'm not going to draw the individual lines, but 3xz times 3xy is going to give us 9x squared yz, because 3 times 3 will give you 9, 2x's y squared, 1y, 1z, and then 3xz times 2x, so 3xz times 2x equals 6x squared z, then 3xz plus 1 equals 3xz. So this turns out to be the same thing as this, 9x squared yz plus 6x squared z plus 3xz. So that means that we probably got it right. When we check it, it turns out to be the same answer. So that means that this is going to be the final answer. And one more thing to notice, just to reemphasize that this 1 is very important. If we left off this 1, then this term wouldn't be there, so we wouldn't get the same answer. So that means that this implied 1 here is very important. Alright, that concludes these examples. I'll see you in section 6.3.